Would you ask Mr. Hancox to come back in, please? Right, Mr. Hancox. Right, ready to carry on?
Yes.
Good, thank you. Yes, Ms. Grange.
Yes, thank you. Yes, we were partway through discussing Trio's replacement design 1, in particular about the ventilation aspects of it. And I want to take you to an email now. If we can look at CAD 6038. This is the second email that Simon Boygill sends following his second survey that he had done. And at the bottom of the page, under the heading Ventilation G5, we can see that he said, if we could just move down the page a little, once the pipework is installed, the riser system could be segregated from the mechanical air extraction by being boxed in. There is a route out to fresh air through the basement and would assume a route out through the top floor, no access to roof as locked. So that's what the surveyor was saying about the ventilation. Now, just to be clear, Mr. Boygill was a surveyor, wasn't he?
I believe so.
Would you have expected the Trio designers to have really scrutinised in detail the route that was being proposed by Mr. Boygill to check that it really was compliant with IGEM G5 in particular?
Yes.
Yes. And we've been looking before the break at what IGEM G5 says about the ventilation. Can we just look at a couple of diagrams that are also in that same section of IGEM G5? If we go to RHX 705, back to IGEM G5 and look at page 54. This is figure 18 that we get in that standard. And we can see the figure title at the bottom, figure 18, internal screwed or welded network pipeline passing through a protected shaft, ventilated directly to outside air. And can we see the ventilation by those little, they're kind of pale green or pale yellow vents that
Yes.
it's showing here?
Yes.
So if you're putting the riser up the stairs, this is giving you an indication in IGEM G5 of how you could then ensure that's vented direct to the outside. Is that correct?
That's correct. Yes.
Yes. And then if we look on to figure 19 on the next page, this is titled figure 19, internal screwed or welded network pipeline passing through a service duct on an outside wall, which is fire stopped at each level. So is this showing us what the ventilation arrangements need to be if it's effectively passing through a series of compartments on its way up the building?
Yes.
And what you're looking for each compartment would be a vent at top and bottom, is that correct?
That is correct.
Where it goes through the floor. And so can we take it, is this a good way of looking at it, that the diagram before was what we should have been looking at in terms of certainly the bits on the stairs and up to the top of the stairs, and this diagram was perhaps more relevant to what was going on at the lower levels of the tower between the basement and the bottom of the stairs. Is that correct?
Yes, you could take the principles of those two drawings and apply them there. Yep.
And when you went to Grenfell Tower, that's effectively what you were looking for when you were assessing whether the ventilation requirements, ventilation arrangements were compliant with IGEM G5?
Yes.
Yes, thank you. Now, just thinking back to Mr. Boygill's statement and what he said about this route, he said that there's route to fresh air in the basement. Do you agree with that?
The fresh air was getting into the basement.
Yes.
Because there were combustion equipment there in the plant room.
Yes.
And that's what that fresh air was for. Because the plant room is a fire compartment in its own right.
Yes.
Which means that the roof of the basement needed to be effectively a fire compartment roof.
Yes.
So if we assume that Mr. Boyle is thinking that air could automatically go from the basement up through the riser shafts, he was mistaken.
Right. Yes. Just to make good the point you said earlier about the fact that there is some fresh air provision to the basement.
Yes.
If we could look at a picture on that, that's TRI 7050. This is a picture from that actually is in your report.
Yes.
And is it right that on the very far left of the picture where we see 10 inches written, we can see behind it a little plinth, is that correct?
Yes.
And is that effectively like a honeycomb plinth that is giving ventilation to the basement?
I believe it is.
Yes. But despite that, you don't think that there would have been sufficient natural ventilation at the bottom of that shaft, is that right? Once it penetrated the roof of the basement and went upwards?
It's a bit different to that. The thing is, that my understanding about the basement being a place of special fire hazard,
Yes.
is it has to be compartmentalised from the rest of the building,
Yes.
from a fire compartment perspective. You couldn't open up, excuse me, the roof of the basement to the utility shaft.
Yes.
That had to be sealed as a fire compartment.
Yes. So really, had that riser been compliant, it needed to somehow find open air
Yes.
at low level.
Yeah.
So coming out perhaps at ground level.
Yeah. Yes, or it is possible, I suppose, and I'm speculating here,
Yeah.
that Mr. Boyle thought that a duct could be sealed up, installed from the bottom of the riser compartment
Yes.
through the basement to that air intake
Yes.
unit,
Yes.
and possibly give effectively as a separate duct,
Yes.
sealed duct, ventilation for the riser cover. But we've not seen any drawings or sketches or even correspondence with that, because that would have been a major structural change to the building.
Yes. Yes, thank you. Yes, there was some suggestion, I think, from Mr. Dolan yesterday that might have been the intention. But I think what you're confirming, and he, to be fair, he accepted, was that's never been written down or documented or outlined in a drawing, that there might have been intended to be the separate duct running through the basement and then up to fresh air.
Yes, that's right. And it's pure speculation on my part, at any rate,
Yes.
as to what he meant.
Yes. And what you seem to be saying is that would be major works, and if that really had been intended, you would have expected to have seen that identified from the outset of this design process. Is that
Yes.
correct?
Or certainly, yes, if it would come up after the decision to box in, then there would have had to have been a drawing, proper drawings.
Yes, thank you. And then, as the riser comes up the building from the basement through the lower two levels, passing the utility shaft and through the store next to the community room, it's right, isn't it, that each of those was effectively a separate compartment from the stairs?
Yes.
And so is it right that each of those had to be completely fire stopped, top and bottom?
Well, they were, yes. Yes.
Yes, but also then you've got this competing requirement to have their own ventilation at top and bottom of the compartment. Is that correct?
Yes.
Now, we can see some images of what you saw when you went to site. If we go to your first report again at RHX 6012, page 30. There's 3 pictures at the top here that you've set out in your report of the riser entering, so we can see on the far left, the riser entering the utilities shaft at ground floor and going through that shaft. Then a picture of it going up that shaft and exiting the utility shaft at second floor. Now, did you see any sufficient ventilation at that point?
No.
Now, we also understand that the riser went through a store next to the community room. Again, did you see sufficient evidence of ventilation at that point?
No.
Now, it was said yesterday in his oral evidence by Mr. Dolan that the louvres at ground floor level to one of the doors provided some ventilation at this part of the route. Let's just look at a picture of that. It's at CAD 6054 at page 13. These were some of the photos taken by Mr. Boigle during his survey. And he pointed to that and he said, well, you can see louvres on that effectively hatch or door that would have provided some, I think he's called it indirect ventilation. Now, did you see that when you went to the tower?
I certainly don't recall seeing that.
Yes.
I am quite certain that if I had, I would have taken a photograph of it. If I'd have seen it in February.
Yes.
If I'd have seen it when I was accompanied by the MPS photographer, I would have asked him to take a photograph of it.
Yes. Looking at that photograph now, what is your understanding of where the riser actually goes through the building in comparison to where that louvre door is?
I don't know where that louvre door is.
Right.
I don't even know if it's actually on the riser shaft where the gas pipe was put.
Right. Yes. So you took photographs in your report of the riser going up each compartment of the building.
Yeah.
And you didn't ever come across that door as part of its route?
No. And I have checked the Corgi report, and there's no mention of any louvre doors or ventilation at levels 1 and 2.
Right, yes. And just going back to the store next to the community room, I think the suggestion was yesterday that that store door might be opened and closed and thereby provide some form of ventilation. I think Mr. Dolan accepted that wasn't a louvred door.
No.
In your view, is that acceptable as a method for ventilating the shaft?
If you're going to start talking about indirect ventilation, you've got to effectively, you want people going in and out regularly, door movements, which creates air movements itself. And a storeroom, no, doesn't do that. That's opened occasionally.
Yes. So if we take the stairs and the stair doors, is that the kind of movement that you might be expecting to create that air movement?
Yes, it's the bare minimum, but it's that sort of stairway. And people coming in through the entrance to the building frequently, whether they're going to the stairs or whether they're going to the lift, they're going to be coming in and out probably over a 15, 18-hour time period.
Yes. Yes. And Mr. Boigle also mentioned in his email, he says there was potentially ventilation at the top of the shaft through the roof vent, although he said he wasn't able to access that. In your view, was the roof ventilation of that design 1, was that adequate in your view?
Probably. There probably would have been enough high-level ventilation, yes.
Yes, because you've got an open vent at the top of the stairs.
Yes.
So even though we don't see a drawing that actually tells you beyond level 23 what was to happen, you're not critical of that?
No.
No, thank you. But I think to summarise, because of the reasons you've just outlined about these lower levels, you are clear, are you not, that the ventilation arrangements were inadequate for this first design of the riser?
Correct.
Yeah. Now, just in terms of how the design developed, if we go to TRI 60263, here we can see a drawing which was for the first version of the design. And if we look at that inset box in the middle, we can see that the intention was to box in the pipework on the lobby side where they've got the laterals to each part of the stairs. Is that your understanding?
Yes.
And was that essentially to deal with compartmentation, because you needed to compartment off the gas pipes in the lobby from the rest of the lobby?
Well, that's the view they took because of mistaking the smoke control system with mechanical ventilation.
Right. So just to make that good, why are you saying that the smoke control system wasn't a mechanical ventilation system?
I understand the mechanical ventilation system basically to be operating most of the time.
Right.
And not if there's just a fire or if there's smoke.
I see. So you wouldn't have had the same concerns that they had about separating out those pipes from that lobby?
At first sight, no, but I'd have wanted confirmation from the building owner as precisely what that system was.
Yes, okay, thank you. And it's right, isn't it, that this design from the outset required oversized holes to be in place between the stair wall and the lobby to enable there to be ventilation of that boxing in back to the stair. Is that correct?
That is what they have done, yes.
Yes. I appreciate you're drawing a distinction between what they should have done and what they did do.
Yes.
And I think I was asking what you think they were trying to do in this. Just thinking about ventilation, first of all, do you consider that this was an appropriate ventilation strategy at this point? In particular, would you have been satisfied that any minor gas leak down the end of one of those boxes in the lobby would have been adequately addressed by the airflow that you get through the stairwell?
Well, you've got I suppose, a smallish volume. I don't know what the volume is. There were no calculations.
Yes.
The general rule of thumb for if you've got a branch off from a shaft is to say anything under, you can probably get away with something like that if it's less than 1 cubic metre. Or if you like, effectively the volume of an oven. And that's the sort of volume you're talking about. I'm not sure that the volume of the ducting in the lobby to serve flat 2
Yes.
was quite possibly over 1 cubic metre.
Yes.
So I've got my doubts that would have worked.
Yes. Yes. And you said at the outset of that answer there was no calculations. Should there have been calculations?
In my view, yes.
Yes.
If they're going down that sort of route, yes.
Yes. And it's right, isn't it, that once you extend thinking forward to the fact that they were going to use this route to replace all of the flats gas supplies, you'd have even more boxing in due course.
Oh, yes.
Yes.
And far larger, for want of a better term, dead space.
Yes.
That's the risk. The theory, as I see it, that they were trying to do was to allow the natural buoyancy ventilation going up the riser to pull out or cause a turbulence and to pull out any gas in air mixture from the ducting.
Yes.
You can do that for a small volume, but the larger the volume, the more problematic that becomes.
Yes. So even taking this portion of the building and what was going on in the stairwells, it sounds like you were very doubtful about it as a ventilation strategy at this point
Yes.
as well. Yes. And you tell us in your first report that IGEM G5 requires a risk assessment to be carried out in respective designs. Is that correct?
That is correct.
And in general terms, can you just tell us what's good practice in terms of what a designer should do when they conduct a design risk assessment?
Well, basically, G5 has got an appendix, Appendix 3, which discusses different aspects, the network pipeline, the meter installation pipe work, the sort of things to be considered. And I've also, in my report, done a bit of a checklist as to what I think should be considered in the design risk assessment. It's not a tick box exercise. It's basically saying, consider this. Does it apply? How are you dealing? And if yes, how are you dealing with it?
Yes.
For example, I'd always have on that checklist flooding, because in some circumstances that could be an issue down at a basement level. In this case, that could be signed off as not applicable, but at least be considered.
Yes. Yes. And are there particular risks for gas supply to multi-occupancy buildings?
There are risks if you have got antisocial behaviour, possible. If somebody decides to leave the flat, taking their cooker with them, and not getting it properly disconnected, and there's a subsequent leak within the flat, you could actually create an explosive atmosphere, which has a significant societal risk. I've come across something similar to that in my own experience, but there's the thing to bear in mind about multi-occupancy buildings is that if you do something stupid, or as a consumer does something stupid, then it affects not only them but other people or other units within the block of flats.
Yeah, yeah. And would you have expected Trio to have done a full design risk assessment for its first design of the riser replacement at Grenfell Tower?
Oh, yes.
Yes.
As a matter of course.
Yes. Now, just some questions about the meter position for a moment, because we know that the original meters had to be moved for this design from the kitchen cupboard to a location closer to the front door. And in your report, you say these meters were repositioned in a place which you have said was in the sole means of escape. Is that correct?
It was adjacent to the sole means of escape.
Yes. Now, Mr. Dolan yesterday was saying that and I'll take you to some photographs in a moment, that the little separate cupboards into which these meters were installed were treated by the Trio designers as effectively a separate room and not in the means of escape. In your opinion, is that a reasonable stance for Trio to have taken?
No, it was a cupboard adjacent, opening onto the sole means of escape from the flat. If you look at the paragraph in G5 which deals with this particular issue and reads it in its entirety, that cupboard, because it's not a bedroom, it's not a study or a living room, it's a cupboard. Might be a biggish cupboard, but it's a cupboard. It's got no windows. It's basically, it opens onto that the hallway there. It's cannot. There's no evidence that it is 30 minutes fire resistance, etc.
I'll come to that. Yes.
Yep.
I think the part of IGEM G5 you might be referring to, if we go to RHX 705 and look at page 38, is it paragraph 5.2.2.4?
5231. Whoops. Citing meters with respect to sole escape routes within individual dwellings. If it is proposed to install a meter in a sole means of escape within an individual dwelling,
yes,
the meter shall be enclosed in a box,
yes,
cupboard, or other compartment which may open onto the sole means of escape from within the individual dwelling, which is at least 30 minutes fire resistant and which has a self-closing door,
yes,
or fitted with a thermal cut-off device.
Yes. And just to be clear, those provisions certainly were not satisfied at Grenfell Tower, were they? And you've got a number of photographs in your report where you can see open cupboards or cupboards with a hinge which could be removed very easily.
Yes.
They weren't 30 minutes fire resistant, were they?
No evidence of that. They certainly
No.
didn't look it to me.
Yeah.
A 30-minute fire resistance door is, fair to say, is heavy-ish.
Yes.
Requires a little bit of oomph to move it.
And you didn't see evidence of TCOs either?
No.
No. And as we understand it from Mr. Dolan's evidence, they weren't attempting to comply with this because they had decided that it wasn't in a sole means of escape. And I'm just wanting to tease out from you exactly why you say it's in a sole means of escape by reference to this standard.
It's a cupboard in my view. You could argue, if Mr. Dolan's, it's not a cupboard, it's not a box, but it is an other compartment. Calling it a room, it's an other compartment.
Yes.
Which opens onto the sole means of escape.
Yes. So what you're saying is this standard is envisaging that you could have a cupboard or other compartment immediately adjacent to the means of escape, but nevertheless it's got to have those features to be satisfactory.
Yes.
Yes.
Well, I suppose in part there's a question of construction about what's meant by inner sole means of escape. Because I think what we were shown was a picture of a hallway in a flat with this area, I'll try and use a neutral word, off the hallway.
Yes.
And I think Mr. Dolan's evidence was they regarded that area as not being in the sole means of escape.
Yes, let's look at that picture. Would that help? If I get it up at MET 3016651. Is that the image you were thinking of, Mr. Chairman?
Yes, I think it probably was, or at least one of them, yeah. So I think, as I understand it, the area in which we can see the meter is through an arch, which itself is open to the hallway leading to the front door.
Yes.
Is that right, Ms. Grange?
Yes.
Yes. That's, as I understand it, what Mr. Dolan was saying.
But this is very much the exception to what was there at Grenfell Tower, in the sense that it was got the arch. The other photograph I've got in the report,
Yes.
showing the door.
Let's go to that. MET 3016558. Is that it there?
That's it there.
Yeah. And can you explain why you say that it
Sorry,
was...
can we just understand what we're looking at there? Is that the front door to the flat?
No, that front door of the flats, sir, is on the right.
Oh, yes, I can see it. I'm sorry.
No,
Yes.
that's to number 52.
So there's an area behind the door that's partially opened.
Yes. That is the door to the cupboard.
Right, so that is the space in which the meter was located.
Yes.
Well, then there's, as I say, I suggest there's a question about whether the meter was in the sole route of escape.
Well, it was in which opened onto.
Well, all right. I mean, we can just discuss this at length, but
Yes.
I was moved to raise the point because of the wording of 5,
Yes.
that particular paragraph of paragraph 5, just to test the argument that the meter was being installed in the sole means of escape. It's a bit ambiguous, that.
Well, certainly the
language.
intention in that
Well-
clause, which exercised our minds significantly for a long period, was to basically say you had a cupboard like that, and it was the door to that cupboard needed to be self-closing, 30 minutes fire resistant.
Well, in the end, the intention of the draftsman has to be collected from the language he uses, because the third party reading it won't know that, will he? So,
Yes.
anyway, there it is. Thank you.
But just in terms of how the industry interpreted that part of IGEM G5, is it your understanding that within the industry it was usual to interpret it as including a cupboard like that which led onto a means of escape?
Yes.
Right. And just thermal cut-off devices, we saw that in the IGEM standard it said you can either have a compartment that's 30-minute fire rated with a self-closing door or a thermal cut-off device. Just help us as to exactly what a thermal cut-off device does.
Effectively, it is a device which will shut off the gas supply when it reaches a temperature at or just above 95 degrees C.
Yes. And is it right that these TCOs can be combined with something called an excess flow valve? An
Yes.
EFV. What's an excess flow valve?
An excess flow valve is a device so that if there is, for example, an open end in the flat,
Yes.
the flow that's going through the pipe will be much greater than is normally accommodated by the meter. And so the pressure differential across the excess flow valve increases, and so a spring then closes the valve.
Yes.
It's an automatic means of shutting down the supply.
Yes, thank you. Now, just looking a little bit more at the design documentation that Trio produced, if we go to TRI 60369, this is the CDM Design Risk Register for the first design, which is dated the 15th of November 2016. And we understand this is the assessment that was done for the first design. You described this in your first report, and I'm not going to take you through all the detail of it because we did that with the factual witnesses. But you described this in your first report as generic. Can you just explain what you mean by that?
Virtually everything that's on there is about work carried out outside in the highway. The majority of work that Trio does on the replacement programme is the replacement of iron mains in the street.
Yes.
And all these things start talking about open trench insertion, open cut, pressure, proximity pressure reduction installations, hazards from commercial, industrial, high street, underground plant.
Yes.
These are all external issues,
Yes.
and tagged on the bottom you've got this reference to multi-occupancy building.
Yes. And at the bottom, we can see that what they do is they give it a score, and if it's above 18 or above, then it's a full design risk assessment is required, and if it's below that, and this was just below it at 17, then no full design risk assessment is required. In your view, is that an acceptable approach?
Not for multi-occupancy buildings.
No. And we can see at the bottom that there was provision for a manual override. Right at the bottom of this form, there was a tick box where you could manually override the scores that this had come up with, and they didn't do that for the first design. Would you always advocate conducting a full design risk assessment for a gas riser design in a multi-occupancy building?
Yes.
Yeah. And that's because of the complexities you've just been explaining to us?
Yes.
Yes, thank you. And I think it follows from your answer that therefore this was a case where there needed to be a manual override.
Yes.
Is that right? Now, we know that there was then a change of design on around the 21st of March 2017. It was discovered that the riser had been built with flanged joints, not screwed joints. And that was a significant departure from Trio's first design. Is that correct?
Yes.
Yeah. Would you have expected that the project manager at Trio would have consulted a senior designer before changing to flanged joints?
Yes, it was a design variation.
Yes. And that the impact of that change should have been fully reviewed. Is that right?
Yes, he certainly should have been discussed and documented. May only have been a short note, but it's documented within the design process.
I think, in fact, the evidence was not that it was a design change by the Trio designers, but then it was a design change introduced
On site?
On site,
Yes.
by the operatives who were doing the work.
Yes, that's why I think I meant to say, should it have been considered by the Trio designers?
Sorry, that's what I understood the question to be.
I wasn't saying was it.
Well,
I
I
was saying,
think what happened. I think what we were told was that the site manager or whoever was responsible didn't pick up this change until it had happened. Well,
Yes.
Of course, he couldn't in one sense, but until it was well established, and it was not a design change introduced by the trio designers.
Mm-hmm. It should have been approved or stopped by the trio.
Or removed, perhaps.
Yes.
Yes.
yes. Sorry, I think I said that the impact of that change should have been fully reviewed. I'm just trying to get a sense of what the process ought to have been at that point.
Yes.
What was the significant practical effect of that change to flanged joints?
Well, a joint is a joint. The possibly speeded up the connection of the lateral to the outlet from the riser.
Yes. But in terms of the compliance of the design, what effect did that have? The fact that they were flanged joints, not screwed joints or welded joints?
My own view is that a flanged joint, in fact, is no more risky than a screw joint.
Right.
In fact, I could point you to data that shows it to be less, have a lower failure frequency.
Right.
So that would be my personal view. We just tend to talk in terms of screwed or welded. One could argue that that's a sloppy language, because we're talking flanged joints are generally found, often with valves.
Right. And if we look at the revised drawing for this, TRI 501223, this is the revised drawing that was done for the design. We can now see that what they've done is, if we expand this so we can see that the photograph and the sketch in the middle, we can see that the boxing in is now extending into the stairwell. Is that correct?
Yes.
And I think Mr. Dolan confirmed that the boxing in was also then intended and did, in fact, because they did this piece of work, went up the lateral as well in the stair. Is that correct?
Yes.
Yes. And then we can see from the photograph above it where the boxing in was to go, that it was to be 2-hour fire-rated boxing. And there's intumescent vents that are shown there. Now, was the use of intumescent vents compliant with gas industry standards at the time?
No.
Can you explain why not?
Well, essentially, I don't see what... well, first of all, we don't mention them at all in G5. And they're only basically there if you're looking at an internal ventilation source. We want, certainly for the gunpowder ventilation, you want it to be to outside or to or from outside. In this particular instance here, particularly given that you're by putting your boxing in the riser and effectively making a protected shaft within a protected shaft,
Yes.
as I would think it. That's actually defeated by putting intumescent vents there.
Right, yes.
Certainly when I visited sites, I saw no evidence of any intumescent vents having been fitted.
Yes.
I appreciate Mr. Dolan said yesterday that the intention was to go back and cut them in. But again, we're back to what is the purpose of those vents? What are the calculations based on?
Yes.
What sizes were they? What function did they serve?
Yes. And you've not seen any of that
No.
at all?
No.
Now, we heard from Mr. Dolan yesterday that the intention was that there was to be boxing in of the entire pipeline, including at lower levels through the community centre, the utility shaft, and into the basement and out. Now, we've talked already about the ability to box in through the basement, so leave that to one side. In your view, was it practical or feasible to have boxed in through those compartments at lower levels to create, so within the cupboard in the community room and within the riser shaft that you photographed before, could you have created boxing in to make that it's a separate shaft at those levels?
I don't think that you still got to generate an air movement in. You've still got to get air from outside. And I don't see where that's coming from.
Yes. And how much work would have been involved in actually doing that boxing in your view?
I think a significant amount.
Yeah. And just to be clear, you've not seen any documentation, have you, that suggests that that was the intention?
No, I haven't.
And just to be clear, you would have expected, would you, a gas engineer, a reasonably competent gas engineer, to have analysed the ventilation by performing bespoke calculations. Would they be bespoke calculations for each compartment where it was a compartment, like at lower level, or would the calculations be for the whole shaft?
A couple of ways going around it. The default position is to try and get to vent sizes that comply with Table 1 of BS 8313, or the table that's in IGEM G5, which is slightly different. Failing that, it means doing some, as I say, bespoke calculations. The sources for that is a British BS 5925, or the more specific hazardous area calculations from IGEM SR25.
Right. So there are a standard industry ways of performing these calculations, is that right?
Yes, if you've got those sort of... It requires a bit of ingenuity, but it can be done.
Yes. And is it right that one of the other potential problems you've identified with this ventilation strategy is whether it would have been adequate once it was all boxed in?
Yes.
Let's just look at a photograph you've got in your first report, RHX 6012 at page 195. Figure 92. This is a photograph taken by someone standing on one of the stair landings and looking down onto the vertical riser. And the red ring is a sleeve, is that correct?
That's correct.
And then that space between the sleeve and the pipe, would an engineer call that the annulus?
The annular gap, yes.
Yes. And if we go on to the next page, page 196, you have marked up a photograph with some red lines.
Yes.
And you've got a label, concrete floor impeding the flow of air.
Yes.
I should say flow. Can you just explain what your concern was about the way in which these pipes would go through the stair floors?
Right. If you go back to approved document B, I think it's clause 841.
Yes.
I think. There is a requirement there that there shouldn't be any impediments for the airflow from bottom to top.
Yes.
In the protected shaft. And effectively what that arrangement, I'm suggesting that it should be cut out that concrete there so that there isn't an impediment or impediment to the
Yes.
flow of gas or flow of the airflow from bottom to top.
Yes, I think the bit of ADB you're referring to is where it says any extension of the story floor into the shaft should not compromise the free movement of air over the entire length of the shaft.
That's the one.
Yes, it's 8.41 of approved document B on page 81. And so...
Sorry, can I just interrupt you? Does that mean you first of all, you have to decide what the size of the shaft or the enclosure needs to be, don't you?
Well, it certainly... If you've got a small shaft or with a smallish cross-sectional area,
Quite.
then effectively you need to make sure that you minimise any impediments or any obstruction at each of the floors.
Well, I was rather assuming you did it the other way around, that you decided how big the shaft, we'll call it a shaft, but
Yes.
it's a box really, isn't it?
Yeah.
What the size or the area of the box needs to be.
Um,
And then you can decide how much concrete, if any, you need to cut away. Is that how it works?
No, it's more the other way around.
Well-
I would say in this instance, you're creating a shaft based on, I suppose, they're minimising the area that's been taken up by this protected shaft within the protected shaft. And when you get to a shaft of that sort of cross-sectional area, the size of vent at each end should be the size, or the same cross-sectional area as the size of the shaft.
Right.
Yes, and so going back to the arrangement that was put in, your view is that was not compliant with approved document B, is that correct?
Yes.
Yes.
I think the concrete and, let's face it, this is very much an afterthought, them boxing in this pipe.
If you'd cut out the concrete across the whole area of the box,
Yeah.
you wouldn't need the sleeve, would you? 'Cause
No, you wouldn't. It becomes redundant.
you could perhaps just as well have made since you've got to break through, you could have drilled, instead of what we were told was a 3-inch hole, you could have drilled a 4-inch hole. Would that have been big enough? And just fit the boxing around the 4-inch hole?
Well, given that the boxing in and therefore creating this protected shaft within a protected shaft, as I say, was an afterthought. So I think the process they would have had to have gone through would involve cutting out. Otherwise, if you started from scratch,
Yeah.
then you'd say, right, you'd have the pipe going up there was a 3-inch. So you are probably talking about an 8-inch, something like that, square shaft. You might have a much bigger sleeve, but again, you need to calculate.
But that was rather why I suggested one starts by deciding how big a piece you need to cut out of the
yes.
corner. Then you box it in.
Yeah.
Otherwise, I don't quite understand how you decide how large the boxing has to be. Well, this may not matter too much, I don't know.
Well, I think somebody panicking, they're told that after they've agreed to box it in, the question, well, how big's the boxing going to be, I think was as small as possible,
Yeah.
I suspect, because of possible obstructions within what is in fact a fairly narrow stairs.
All right. Thank you.
And I think we can deal with this point very briefly because it wasn't contested by Mr. Dolan. The boxing in was supposed to be 2 hours fire rated, but when you considered the technical data sheet, it didn't provide that fire rating, did it?
That's correct.
I think we saw it had 88 minutes fire resistance. And we also know that the intermittent vents were not installed, at least insofar as you could see the work in the stairs by the time of the fire. Is that correct?
That's correct.
I think Mr. Dolan said yesterday that it was the intention to cut those intermittents into the boxing in at a later stage. Would that have been feasible to do it that way?
It would have been feasible.
Yes. But have you seen any documentation which suggests that was what was planned?
No.
No. Now, oversized holes. We know that there were these oversized holes that were intentionally cut around the pipes between the stair and the lobby to allow ventilation through the boxing in. And we know that that boxing in was not completed by the time of the fire on the 14th of June. Is it right that it was completed on the stairwell side up to level 22 on the vertical riser?
I believe so. Yeah, I've got photographs.
Yes, I think you say in your report it wasn't completed at level 23, but at the very top, but it had
Yes.
gone right up vertically to 22. 2.
Yep.
But on the lobby side, the laterals had been boxed up, completely boxed up to level 5, but above that, it was just that on the floors where gas was to be provided, you just saw battens,
Yes.
which had been put in, waiting for the boxing, but the boxing in wasn't actually there. Is that correct?
That's correct.
And in your first report, you've drawn attention to the fact that it is possible in theory that smoke could have entered from the lobby side through those holes, up the boxing in the stairs, and then potentially back through holes. It was a breach of compartmentation.
Yes.
You've drawn attention to that.
That is a possibility.
Yes, but you're not an expert in smoke spread or
No.
how smoke might move.
No.
So is it right that you've just merely drawn attention to this as a breach of compartmentation in your report?
Yes. Yes, we've got the photographs which shows the smoke staining.
Yes, I was
One
going to
goes
just
up.
look at some of those. So if we look at, in your first report, at RHX 6012, page 165, we can see at level 5 2 images of the stairwell.
Yeah.
And there, this is when, after the fire, when the boxing in has been taken off. Is that correct?
That's correct.
And
These,
here we-
yeah.
Sorry.
The photograph at the top came from Barbara Lane's report.
Right, yes.
The photograph underneath was taken by the Metropolitan Police photographer when I visited at the end of May.
Yes.
And as you can see, the internal part of the ducting is in pristine condition.
Yes. So at the top, we can just about see that the boxing in is still there at that point, and then by the
Yep.
time the second photograph's taken, it's been removed.
Yes.
So you can see what was behind it. And then if we go and look at floor 9 on page 169, here we can see that there is smoke staining within that boxing in. Is that correct?
That's correct.
Yeah.
And you can see, particularly on the left-hand side, how you've got smoke staining on the riser side as well as the lateral.
Yes. And if we go to floor 13 at page 173, you've also marked in the top photograph, this was a photograph taken by Dr. Lane not long after the fire, I believe, and there is a missing panel at the end of the boxing in on the stair. Is that correct?
That's correct, yes.
But is it right that we simply don't know when that missing panel might have fallen out, whether it was not there because the work was unfinished or whether it had fallen out during the fire and removed? We don't know that, do we?
We don't know that, that's correct.
Yeah. And is it right, I think you also saw a missing panel from the boxing in on floor 21?
Yes, there was another floor, yes.
Yes.
Yeah.
And if we look then at page 178, which is floor 17, here we can see there's smoke staining along the lateral and slightly less smoke staining in the vertical at that point.
Yes, yes.
And then at floor 18, if we go to page 179, this is a floor, is this right, where there were no flats 2 who required gas, so there was just a vertical riser at this part.
That's correct, yes.
And what we can see is there is some smoke staining at the bottom, but less smoke staining towards the top. Is
That's
that
correct,
what
yes.
you referred to? Now, in your opinion, during the build, should Trio have done something about those oversized holes while the work was incomplete and that boxing in was not yet finished?
I must admit that with hindsight, the answer is yes. But I don't think it would have been normal practice whilst the job was ongoing, unless the building owner or TMO, as the responsible person for the building, had pointed it out to them.
Yes. We did see, I drew it to the attention of Mr. Dolan yesterday, that there was an email from Cadent, I believe, drawing attention to the fact that there were these breaches of compartmentation during the works. And and drawing that to Trio's attention. And the response came back from Trio, well, yes, we know that the works are incomplete. And I think it was at a time when they'd been removed from site due to the asbestos incident.
Yes.
In those circumstances where they had it specifically drawn to their attention, does it change your answer?
Well, if they were advised of it by the client, then yes, they should have done something. It would have meant going back to the TMO to say, I know we've been chucked off site, but there is this work which we feel should be done.
Yes.
And I'm sure that the TMO, as a responsible and prudent operator, would have agreed with that.
Can you just explain that? Because why does it make a difference if the TMO simply draw Trio's attention to something of which they were already perfectly well aware, namely that the
Cadent, I think,
well,
whichever said the Cadent drew their attention to it.
Well, it doesn't matter who it was.
Yes.
Why does it make a difference if someone drew their attention to the incomplete work of which they were already themselves well aware?
It's a question of... I don't think the implications of the incomplete work would have been understood or fully understood.
So would I be right in understanding that in your view it would make a difference if someone had said to them, look, I know that we both know the work's not finished, but you should realise it might have these implications.
Yes.
Right. But simply to say the work hasn't been done wouldn't really make much difference.
No, it sounds as if they were being fobbed off. But you're then into client-contractor relations and who's in control.
Yes, I was just simply trying to understand to what extent you would criticise Trio for having left these gaps unsealed at the time when they were still working on the installation.
I don't believe at that time that contractors generally were aware of the importance of not leaving those holes unsealed.
So I think what you're saying is you wouldn't particularly criticise them for not having done it unless someone had not only told them that the work hadn't been done, which was self-evident,
yes,
but that there was a reason for doing something about it.
Yes.
In which case you would expect them to respond to that.
Yes.
Yes, thank you. I thought that's what you meant.
Yeah.
Yes, I think if we pull up that email, it's at TRI 60985 at page 3. So this is an email, if we just go back a page perhaps and just see who it's from Mary Ryan at Cadent to Stephen Johnson, who we know was the design manager, copying in Matthew Dolan on the 21st of March 2017. And she says, as we discussed on Friday, Pat has visited Grenfell this morning to review the works completed, paying particular attention to the flats where Holland Gas have undertaken internal works. And then if we go to the top of page 3, it says, the agreement with the local authority was to install the new supply in the fire exit stairwell and box in to meet their evacuation requirements. This has not been completed, although there are ventilation holes throughout the stairwell, which, if a fire incident did occur, would create a more unsafe situation. Now, that's the email that's sent by Cadent. In your opinion, would a reasonably competent contractor at that point make sure that those ventilation holes were fire stopped while the work remained incomplete?
Yes. Yes.
And just to be absolutely clear on your evidence, are you saying that before that's received, you wouldn't have expected a reasonably competent contractor like Trio to have appreciated the need to fire stop those holes while the work was incomplete?
I'm afraid I think that's the real world, yes.
Yes, thank you. Now, the boxing in that was part of the second design, which was boxing in not only in the lobbies but also in the stairwell, in your view, did that create problems in terms of future inspection and maintenance?
Yes.
Now, we heard yesterday from Mr. Dolan that he said inspection could have been achieved either by the intermittent vents once they were installed or by cutting the boxing out for inspection. So we know the intermittent, well, we're told that the intermittent vents might have been on the stairs, but I think at the lower levels he was saying you'd have to cut out the boxing. Is that a satisfactory method in your view for allowing future inspection and maintenance of those pipes?
I would expect for future inspection and maintenance that inspection hatches would be cut into the boxing. If not, then certainly there needed to be screws and screwed arrangements. And in fact, if you looked at the photograph of the boxing in on floor 5, you can see that there were screws which could be used to take off the panel to inspect. But the norm is to fit an inspection panel which you can unclip or unscrew. You can put a gas detection instrument in. You can put a duct camera in to look for any signs of any corrosion. And that would be the norm.
Yes. Now, we know that there was a second design risk assessment that was completed for this revised design. That was in March 2017. If we can go to that at TRI 501218. This is dated the 24th of March 2017. And this document tells us that the automated score still falls below the level required to trigger a full design risk assessment. But this time, the manual override has been triggered. We can see that at the bottom of the page. Can you see it says manual DRA override needed and the comment welded rider system and specific ventilation requirements. And at page 4, we then can see the detailed design risk assessment that has been carried out. And we looked yesterday in particular at the MOB's multi-occupancy building specific hazards between lines 19 and 20 and some of the notes that were put in there. Now, I'm not going to go through all of those notes, but it was accepted yesterday by Mr. Dolan that this was too generic and not specific enough. And can you just confirm that that's your view as you set out in your written report?
My view on this is that it's totally inadequate.
Yes.
Not just generic, and it's totally inadequate.
Yes. And in your first report, as you've mentioned already, you've given a list of what you would have expected the designer to consider, both in terms of the 3 topics we have here, breach of compartmentation, failure mode expansion, thermal expansion and inadequate ventilation.
Yes.
There's a lot more topics you would have expected within those 3 topics to be considered. Is that correct?
That's correct, yes.
And you've also given a list of other headings for multi-occupancy buildings, like flooding, corrosion, means of escape.
Yes.
That, in your opinion, should also have been considered. Is that
correct.
right?
That's correct, yes.
And so it's essentially for those reasons why you've just said that your evidence is this was totally inadequate. Is that correct?
Yes.
Thank you. Now, I just want to look at what you say in conclusion about all of this design process and this riser project at the end of your report. So if we can go to page 210, RHX 6012, page 210. At paragraph 446, you say this. You say, I am of the opinion that the ventilation of the riser and laterals had not been the subject of a sufficiently rigorous design process, and that the design was not and would not, on completion, have been compliant with IGEM G5 Edition 2, BS 8313, approved document B, and the regulatory regime described above. Consequently, I believe that the safest course of action open to Cadent Gas Limited, once the option of running the replacement riser and laterals up the outside wall of the building had been ruled out by the TMO, was to refuse to replace the pipeline on the grounds of being, let me go over the page, on the grounds of being unable to comply with current legislation and standards and to compensate the residents accordingly. So, and do I take it that that conclusion hasn't changed?
That conclusion has not changed.
Yes. And it's right, isn't it, that it's your view that the gas transporter could have refused to connect these properties to gas had they wanted to, had that been their conclusion about the risers?
I believe so. I believe subsection 9 of section 10
Yes.
of the Gas Act gives that gives the gas transporter the option of refusing to make a supply available.
Yes. And is that provision well known and used in the gas industry?
I don't believe so.
Do you consider, in your opinion, that the gas industry ought to consider the option of refusing to supply gas on the basis of safety more often?
Quite possibly. I think they should be much more aware of that. Whilst I'm sure that you could end up in a few court cases, it's something that they, at the moment, there has been for years, a culture that if a gas supply is cut off for an escape, it will be replaced, come hook or by crook.
Yes.
Even if that means non-compliance with current standards. And that culture possibly needs to change.
Yes, thank you. Mr. Chairman, there's one remaining fairly sizable topic left, which is recommendations.
Yes.
But I'd like to deal with that in one go, if I could.
Well, I think that's all right.
Could we take the afternoon break now and then resume again at an appropriate time?
Yes, well, we can do that. I'm sure it is quite a sizable topic, but you're not going to have any difficulty in...
Oh, no, sorry, I'm not signalling that I've got a problem finishing. It's just, it seems odd to start the topic and just do 5 minutes and then break.
No, quite. We'll break now, and we'll take our afternoon break a little earlier than usual, Mr. Hancox. So we'll stop now. We'll come back at 3:25 and then move on to the next topic. All right. Thank you very much. And please don't talk to anyone about your evidence. But you probably won't have much of a chance to.
No.
All right. Thank you. Would you like to go with the usher?
Thank you.
Right. 3:25 then, Miss Grange. Thank you.
Thank you.
Yes, would you ask Mr. Hancox to come back in, please? Thank you. Right.
Yes.
Ready to keep going,
There
Mr.
we go.
Hancox? Thank you very much. Yes, Ms. Grange.
Yes, thank you. So now on to the topic of recommendations. So you make, at the end of your report, and in the light of all the evidence you've considered and the conclusions you've reached,
Yes.
you have made a number of recommendations for the panel to consider. And the panel's decided that it would like to hear from you on that today, because gas is quite a self-contained topic. So
Yes.
we have time to do that now. Now, the first recommendation is about a replacement decommissioning riser programme. In your evidence, you've identified a number of problems with old residential supply one, in particular the lack of sleeving of risers and pipes being run through unventilated voids.
Yes.
And we've understood from your evidence that those design features were permitted in buildings constructed before the 1st of December 1972. Is that correct?
That's correct, yes.
Now, let's just look at the key recommendations you make about this in your first report. So if we go to RHX 6012 at page 220, and if we look at paragraph 468 and 469, I want to look at. You tell us at 468, many high and medium rise blocks of flats were designed and constructed prior to the effective introduction of the Gas Safety Regulations 1972, which required pipes to be sleeved through walls and floors and not to be placed in unventilated voids. To my knowledge, there are a significant number of blocks of flats in London, Scotland, Central Belt, and other cities in the United Kingdom of similar vintage and with the same sleeving and ventilation issues as exhibited by residential gas supply number 1. And then you say at 469, therefore, I believe the inquiry should recommend the gas transporters and by implication other interested parties such as the HSE, Ofgem and local authorities and housing associations with private gas networks have a replacement decommissioning programme for internal risers and laterals that are not compliant with the gas safety regulations from 1972. So that's your recommendation. Now, I just want to clarify something about that last sentence at this stage, where you note that it would be buildings that are not compliant with the gas safety regulations 1972. Are you referring specifically to buildings which, by virtue of their age, did not have to comply with what we would now consider basic safety features, such as sleeving and ventilation that were contained in those regulations?
I'm particularly aiming at, that should be aimed at buildings which do not have sleeving or which have pipes going through unventilated voids.
Yes.
Now, they're the two, I think, principal risk factors of pipes of that age, to which you would then add on the possible effect of long-term corrosion and that we also saw on residential supply number 1.
Yes.
Yes.
Yes. And just to be clear, you're not saying, is this right, that we should replace or decommission pipes in modern compliant buildings just because they don't meet all the prescriptive requirements of those 1972 regulations?
No, it's
No.
basically, I'm saying, effectively, if you've got risers which do not have sleeves, which are concreted into the floors, and or have got unventilated voids, something should be done about them.
Yes. And can you confirm that the HSE itself has been focusing on gas supply to tall buildings recently in terms of its work?
Yes.
And can you confirm that that work includes, in May 2018, the HSE started an inspection programme on the arrangements for managing the integrity of pipes in buildings over 6 floors? Is that correct?
That's correct.
And to do that, they issued something called a topic pack. Is that right?
That's correct.
We'll come to that in a moment. And they reported back on this in February 2020. Is that correct?
That's correct.
Now, the topic pack and the report, those are public documents. Is that right?
Yes.
And in your view, has the HSE investigation been extensive into this?
I've been reasonably extensive, yes.
And is the report that's been provided by the HSE, I think you say in your supplemental report that it's an authoritative and reliable report, is that correct?
I believe, yes.
Now, if we go to the topic pack at RHX 6015, we can see, here it is, it's a topic inspection pack, and it's dated May 2018. And was this the document that was issued by the HSE to inform how their inspection programme would work?
Yes.
And if we go to page 7, at the bottom of the page, we see under 7.2 benchmark, we can see it says this. It says the benchmark standard for pipelines is defined within the Pipeline Safety Regulations 1996. And then it quotes Regulation 13 about maintenance dictates that the operator shall ensure that a pipeline is maintained in an efficient state, in efficient working order and in good repair. And then the HSE has added so that in all cases there is a nil/negligible chance of a significant injury occurring. Now, do you take that last sentence and the reference to nil or negligible chance of significant injury to be the standard at which the HSE expects that all gas transporters will keep their service pipeline safe to?
Yes.
Now, is it your view that a proactive programme to replace older steel risers that fall into the category you've just described is required in order to achieve that standard?
Yes.
Now, in your supplementary report, you give some more detail on different replacement philosophies that are known about in the gas industry, i.e. different approaches to addressing gas work. You refer to something called the reactive philosophy. Is that where replacement is only considered where the riser has failed completely?
Usually, yes, basically as a result of a public reported escape, or as in the case of Grenfell Riser 2, where their inspection finds a leak.
Yes.
And they have to cut off the riser.
Yes. And then you refer to something called predicted replacement, and is that understood to be where data analysis is used to predict the imminent failure of a riser, such that action is taken before an escape occurs?
Yes.
So you've got to have data available to you to be able to make that prediction, is that correct?
That is correct.
And then you distinguish between those things and something called preventative replacement. And is that where there is a systematic programme of replacing risers and laterals with known risk factors, such as pipes being concreted into floors or with inadequate ventilation?
Yes.
And what you're saying is you're recommending a systematic programme of replacement for those with known risk factors already, is that correct?
That's yes.
And just to be clear, is it your opinion that a serious gas incident is likely to occur if a wholly reactive philosophy is continued to be employed?
Yes, I believe the probability of serious gas incident is greater in those circumstances.
Yes. And
are you able to help us as to how likely you think it is? I mean, is this something that is
no,
a very a significant possibility?
There's a paucity of data, including likelihood of failure of riser systems and likelihood of failure of riser systems leading to an incident. Mm-hmm. And I suppose the industry is in a situation where it can either say, we haven't got enough data, do nothing, or we recognise these factors and we do something about it. Mm-hmm.
Yes.
No, but my question was really a response to your previous answer. You were invited by Miss Grange to confirm that you believed that there was a probability of a serious gas incident. I'm sorry, I haven't got exact language. And I wanted to get some sense of how serious this problem is, and whether you think that there's very likely to be a serious incident or just a fairly remote possibility of an incident, or where on the scale between them.
It's a less remote probability. So in other words, it's likelihood of a serious incident, fortunately, is going to be low. But if you only have a reactive policy, it is more likely that there will be,
of course,
a serious incident with just a pure reactive policy.
All right, thank you.
Yes. Now you say that a predicted replacement strategy relies on data analysis. Now, is it realistic that a gas transporter will be able to get sufficient accurate data to inform that sort of replacement strategy at this time?
As the industry is currently organised, probably not. I think there needs to be a coordinated national approach that takes in all of the gas transporters and a pooling of data. I think that would be essential. Possibly to the HSE, acting as referee. But essentially, to get the data, there's got to be access.
As in access to the buildings?
Yes. Access to the building, to the different parts of the building.
Yeah, so I think what you're saying is if you tried to do some kind of predictive replacement programme, the big challenge is obtaining proper data about the condition of pipework within many of these buildings.
Yes.
Is that correct?
Yes.
And you've said the main problem is access. Are you concerned that just like at Grenfell, these older risers are likely to be built going from flat to flat in many buildings?
There'll be a significant number of where that is the case, yes.
Yes.
It's a common feature, I believe, of buildings of that vintage.
Yes. So if you were trying to get better data on these buildings, that requires you to be able to get access to an awful lot of flats to assess that pipeline. Is that correct? It does. And access for inspection also depends on people being at home at the time and also willing to provide the access. Is that correct? Is there also a problem, in your view, about visibility of the pipes because of their location in buildings, in terms of being deep in buildings or deep in concrete within buildings?
Some of the very old systems will actually be embedded in the fabric of the building, in other words, within the wall, as well as in just going through floors and walls. But this is where one's looking at gas systems which are 50 plus years old.
Yes.
And some of them will even be pre-war.
Yes. And does it follow from what you've said that any predictive replacement strategy would be difficult to achieve to reliably inform a safe replacement strategy? Is that what you're saying?
I am sceptical that sufficient data will be available, or that any sampling will be representative of the riser. We heard yesterday that Cadent actually did pretty well to get access to 40% of the properties in Grenfell. And that's a much higher figure than I have heard as a generalisation from others. So the whole access issue, getting data to predict when, if you like, the other risers at Grenfell would have failed. I think the jury's out on that.
Right.
On reading the HSE report.
Right, yes. Now, if we go to your supplementary report at page 12, that's RHX 6020 at page 12. You tell us at the bullet point at the bottom, just before paragraph 23, you say A preventative replacement programme will involve the replacement of risers before imminent failure is likely. On the other hand, a preventative replacement programme targeting those risers with known risk factors should reduce the risk of a serious gas incident occurring and will not be overly hampered by the absence of data from difficult to access locations. So is it right to understand that any preventative programme that you're proposing would identify certain risk factors and then require buildings at highest risk to be replaced first?
Yes.
So you're not saying you take all the buildings that were pre-1972 that appear to have no sleeving and no ventilation, and you just blanket replace all those risers? Are you saying that any programme would need to prioritise those that you should be approaching?
I think that certainly is your starting point. That would be your basic data. There may be buildings you just cannot get in, or you can only get into one or two locations. And my concern about a predictive approach is that if you can only get into one or two flats or one or two locations, it may not be sufficient to form a valid judgment. So it's almost a mix of trying to prioritise what you're doing. But I am concerned that at the moment, was it Cadent saying that they are, I think they said the other day, 80% of their current replacement is reactive.
Yes.
20% of it is what they call proactive. Those figures concern me. That is basically a reactive programme.
Yes. And when you talk about known risk factors that put your buildings into this initial pool of buildings of concern, just to be clear, are we talking about buildings with unventilated voids and no sleeving?
Primarily, yes.
Are there any other risk factors that would be easy to identify that you think ought to qualify them for this kind of programme?
Yes, 3-inch and 4-inch or even 6-inch screwed steel. So the screwed joints bigger than 2-inch.
Yes.
Are no longer allowed, not just in this country but in Europe, for gas work, basically because of the probability of leakage from them, their failure rates.
Yes. And how would you understand that buildings with those risk factors be identified?
Combination of continuing with surveys but also liaison with building owners.
Yes, so there'd have to be a proactive engagement with building owners.
Oh, definitely, yes.
To identify this pool of buildings. Is that right?
Yes, I believe so.
Well, can I just intervene again there, because I was going to hold these questions back for the end of this part of the examination, but since you've raised the question of getting in touch with building owners, is this a problem which, in your view, or these problems, the two that you've specifically identified, are they limited to buildings in multiple occupation?
There is a significant problem in parts of the country of finding out who the building owner is in the first place. And the problem is that many building owners and residents consider, or certainly give the impression of considering, an inspection of the gas system as an unwanted intrusion.
I ask the question because there are some buildings in sole occupation which have parts which have solid floors, probably concrete screeds.
Yes.
Particularly in the areas of kitchens, where there may be gas boilers or gas cookers and potentially unsleeved connections. Should we be having them in mind as well when we make recommendations for replacing unsleeved pipework?
I assume you're talking about the installation pipework for the individual dwelling.
This is the pipework before it reaches the meter, and therefore is the responsibility of the gas transporter, if I've understood it correctly.
Yes. Then that is something that I would have thought would be dealt with under the standard replacement, including for individual properties. Then that I'd have thought would have been dealt with as part of the iron mains replacement programme.
So you think we can safely ignore buildings in sole or single occupation?
I think they're down the list of what you can consider.
Maybe, but I'm just really want to know whether we're looking at all these things through the prism of Grenfell Tower. Of course we are.
Yes.
But nonetheless, if we're being invited to make recommendations which are related to the existing gas infrastructure, there are many buildings which are much older than Grenfell Tower, which will have gas pipework, possibly of some antiquity, and which may have solid floors, therefore concrete or similar types of material, through which or near which the gas pipes are running, which raises the problem of corrosion or the heightened problem of corrosion and so on.
Yes.
Should we ignore those or should we take those into consideration?
I think the industry must not forget it. And certainly when I was active in British Gas, there was a service replacement programme. To what extent a lot of services were replaced in advance of any mains replacement. So it's certainly should be on the list of assets to be considered for replacement.
Thank you. And the other thing is this, we, again, for obvious reasons, we're looking at this principally through the prism of the high-rise building.
Yes.
At the moment, high-rise buildings are conventionally identified as being buildings with a story over 18 metres in height. I take it that these problems are not limited to buildings of that height.
True. Yes,
So
I point out that we, elsewhere in the report about recommendations relating to what you might call medium or rise.
But these problems, in a sense, are of a generic nature.
Yes.
And so if we're thinking about making recommendations, we would be unwise to limit them to high-rise buildings.
Yes.
Yeah, thank you.
Yes.
Yes, Ms. Graves, sorry, thank you very much.
Yes, thank you. Within any proactive programme that might be recommended, is there still a place for gas transporters to be identifying and assessing risks in the way they are at the moment, as described by Cadent, and thereby identifying the most dangerous building for earliest replacement?
There's a place for it, yes. But it's if they can identify the risk.
And you're doubtful that they can because of the access problem?
Yes.
Yes. Now, you've mentioned it just briefly already in your answer to the chairman, but you go into some detail in your supplemental report in drawing on your experiences with something called the Iron Mains Replacement Programme.
Yes.
Now, can you just describe very briefly what was the problem with the iron mains?
Well, basically, the work that was done in the early days of British Gas, so the early 70s, identified that the majority of incidents involving casualties and explosions came from small, that's 3-inch and 4-inch cast iron pipes, particularly where they were in streets where there was a sealed surface all the way to the property, or where the property had cellars. So and there was a risk with the smaller diameter mains having less beam strength, so any ground movement, they would break.
Yes.
So you get plenty of gas coming out of the gas escape.
Yes.
Getting into a property, source of ignition, explosion.
Yes. And is it right that initially those were being dealt with by a wholly reactive policy, so only being replaced when they were falling apart?
Yes.
And replacement being a last resort?
Yes.
And was that approach challenged?
There were engineers at the time who expressed their views quite forcibly.
Yes. And did that lead to a report by somebody called Dr. or Professor King? Is that correct?
Well, the incidence of escapes or explosions it was generated by explosions over the Christmas period of 76 to 77. So Anthony Wedgwood Benn was the minister at the time.
Yes.
Agreed with the then chairman of British Gas that there should be a report produced, an analysis, and that happened. And out of that report came a major risk program to replace the high-risk mains, which
Yes.
were basically the 3-inch and 4-inch pipes
Yes.
in certain locations.
And that was a proactive mains replacement programme.
Oh,
is
yes.
that correct?
Yes.
And just so we're clear, you're not saying that the problem with the iron mains is exactly the same as the problem we have with these risers
No.
in these buildings you've drawn attention to. But what you're saying is there's an analogy here in terms of there was a move from a reactive strategy to a proactive strategy. Is that correct?
That's correct.
Is that
I can see the
correct?
similarities with what was happening, incidents and the reaction to the incident.
Yes. And was a programme put in place to prioritise or target the mains most at risk first?
Yes, we went after 3-inch cast iron mains in what we called hazard A areas, which is where the either the front of the house was actually butted onto the footpath, or there'd be, say, a 1 or 2 metre wide front garden that had been concreted over.
Yes.
And we did those.
Yes. And you mentioned in your supplementary report that following the decision to go with this proactive programme, there was then a rapid increase in pipe laying teams with supervisory and technical staff with the ability to go and replace these mains. Is
Yes,
that correct?
That's correct.
And that work is still being completed, is that right?
Yes, there is still an iron mains replacement programme.
Yes. And there is, in fact, a regulation in the 1996 Pipeline Safety Regulation which deals with how the HSE will work with transporters on their programmes to replace iron pipelines.
That's
is that
correct?
Yes. Now, if we just go back to the topic pack for a moment, at so RHX 6015 at page 10. We can see at the bottom of the page, at the second row from the bottom, this is in a table of questions that the HSE was asking of relevant buildings. And the question is a clear risk-based prioritisation system in place in relation to inspection, maintenance and condition replacement? Now, there's no doubt, is there, that the HSE does expect gas transporters already to have a risk-based system in place for assessing their gas assets.
Oh, yes. Yes.
And the inquiry has seen evidence that Grenfell Tower was surveyed in 2016. And can we agree that that survey did consider the risk of the existing residential supply one and did make a decision to replace the whole of the riser at some point? So a survey was done here, a problem was detected, and the upshot was that eventually that whole riser was going to be replaced through the new riser. Can we agree that that action did happen?
Yes.
Was that not an example of a survey process working to deal with the problem of these older, potentially unsafe risers?
I think if they'd eventually got into the flat where severe corrosion had been seen, I would say yes. It's partly on the way there, yes.
Yes. So I think what you're drawing attention to is it was then 8.5 months to the fire and still nothing had been done in terms of their more detailed corrosion survey work.
Yes, yes.
So why is that, in principle, not a sufficient way to deal with the problems with these old steel risers?
The impression I have is that possibly, certainly in London, Cadent are swamped by sheer number of properties that they're looking at.
So does it follow that you're doubtful that the problems will be adequately addressed by way of their current processes?
Yes, I am doubtful.
It might be said that some gas transporters already account for the problems of access in their surveys. For example, if they can't see a pipeline, they give the building a higher score and choose to assess it more frequently until there is remedial action. If a gas transporter already had that approach, why would there be a need for a preventative replacement programme?
They'll keep going back year after year to try to get in to inspect and do nothing. Because they can't get in.
Yes.
You've got to break that loop of keep going back year after year and trying to get in to collect the data.
Yes. Now, in general, and I think you confirm it in your supplemental statement, but I just want you to confirm it now. Can you confirm that you've read Mr. Harrison's, it's his third inquiry statement, it's his fifth statement in time from dated this year, I think March this year, and considered the reasons why he says a preventative replacement strategy is not necessary given other processes and procedures that Cadent has in place?
I have read his statement. I note his reference to resources and costs and as opposed to safety. And I do not have faith that they're getting the data necessary for a risk-based predicted replacement
System. Yes. So can you confirm, has your view on this recommendation changed at all as a result of reading his evidence?
My view hasn't changed, no.
Yes. If we go to the HSE report of February 2020, this is RHX 6014. So here is the report that the Health and Safety Executive published. And we go on the third page. Sorry, here's the front page of the report, and it's headed Gas Supplies in High-Rise Multi-Occupancy Buildings Inspection Findings. At page 6 of this report, if we go on page 6 of this clip, we get the executive summary. And if we just look at paragraph 2.5, we can see it says a lack of quality records in relation to the design, installation, inspection and maintenance of gas networks supplying high-rise dwellings is a common observation and restricts the operator's ability to provide a robust demonstration of network integrity. Given the practical difficulties involved in providing assurance of the condition of the network, further work needs to be undertaken by the industry on the basis by which risk-based decisions on inspection frequency and replacement are made. Now, does that tell us that the HSE considers that there's more work to do before they are satisfied that gas transporters have a sufficient surveying and reaction strategy to deal with this?
I believe so, yes.
And is it true that the HSE is still currently investigating this issue?
As far as I'm aware.
Yes. If there's a problem with the risk-based systems that gas transporters are using, wouldn't the HSE be the better body to decide, on the basis of the evidence it gathers, what to do about gas transporters whose risk-based systems are inadequate?
A strong argument can be made that they are the appropriate body, yes. That doesn't stop me having an opinion.
Yes. Now, it's been said, and you've already alluded to that, Mr. Harrison makes these points, he makes a number of points in his statement, but he also makes these points, that your proposal will cost a great deal of money, that it will result in timing and workforce issues which will drive up costs for customers, that it will be disruptive to a lot of customers, and it's also been said that it's not proportionate. What's your response to those concerns about it being disproportionate to the size of the problem?
Prove it. My answer would be to ask him to prove it.
And what do you mean by that when you say prove it?
I believe there is a problem, and I believe it needs to be tackled. And to try to dismiss the concerns by saying it's all disproportionate, I'm afraid is I don't accept straight off. I think he needs to demonstrate that, like proportionality, is what the risks are. For that, they need data.
Yes.
And in the light of what we've seen at Grenfell, there's, I think some work has got to be done.
Yes. He has said that a conservative estimate of dealing with this problem, as you propose, would be somewhere in the region of £170 million. Yeah. He's estimated that something like 8,300 risers might fall within the definition, your definition of those that would need addressing. And he estimates approximately £20,000 per riser, which is how he gets to around 170 million. But do I take it from your previous answer that doesn't affect the fact that you still think that needs doing, regardless of whether the costs might be in that order?
I see that there is a population out there that's getting older and older. The population of assets that's getting older and older. And with that, if there is any deterioration through corrosion, etc., there will need to be a programme to deal with it. Otherwise, they're going to get swamped with incidents, and there could well be a serious gas explosion, etc.
Yes. And you've said in your report that you wouldn't be able to give any indication as to the timescale in which this kind of proactive work would need to be undertaken. Can you explain why it's difficult to predict timescale?
Well, again, it's down to data. Just how many buildings are out there, what state they are in, what is their predicted life. At one time, there was talk in the industry of a steel system into a building of having a design life of 25 years. Well, we're well beyond that in respect of high-rise buildings. At other times, there's a discussion in terms of the length of time that you'd expect a gas main to be in a road. And I think you're talking 80 years. Well, that takes you to what? 1940? So anything that's pre-war would be covered there.
Yes.
So I'm very conscious that we've been living on, the industry has expanded considerably over the years. And assets are getting older. And if they've got issues, potentially on corrosion particularly, then they will come home to roost.
Yes. Now, you mentioned in your supplementary report that currently there is a possibility of gas supply converting to 100% hydrogen. Is that correct?
That's correct.
So that would be a different fuel replacing natural gas?
Yes.
Now, 100% hydrogen is not yet approved for use in multi-occupancy buildings over 5 floors, is it?
No. Well, the current thinking is that no evidence that it can be done safely.
Yes, right. So is it right that even if that change happens, it will still be a number of years before there's full conversion?
Yes.
Yes. And does it follow that, in your view, there's still a place for a recommendation about a proactive strategy for buildings with the unsafe features you've identified?
Yes. We don't know the effect of hydrogen, particularly for multi-occupancy buildings. We don't know whether the domestic consumers will be able to be supplied with hydrogen, because the calorific value is about a third of that of natural gas, and so you've got capacity issues on the gas networks. There are a lot of unknowns with hydrogen. There's a there's a possibility. I was flagging it up there, and it's made as a possible, as an unknown.
Yes.
That may well be into a situation in 10, 15 years' time where there's a decommissioning program because of hydrogen.
Yes.
I don't know.
Yes, I understand. Now, PIVs now, and accessibility of PIVs. Your second recommendation relates to these. And if we can look at your report, your first report at RHX 6012-220, paragraph 472, you're referring in the previous paragraphs to the problem of PIV valves boxes being lost, and we've already discussed that today. I'm not going to go back over that.
Yeah.
And you tell us at 471 that the current inspection practice is to check the accessibility of the PIV at the same time as the rest of the gas infrastructure for the block of flats being inspected, and this can be as infrequent as 10 years, which in your view is too long.
Yes.
And you tell us that you're aware that under the gas safety management regulations, each gas transporter is required to undertake a thorough review of its gas safety case every 3 years and is required to submit a report of that review to the HSE. And you say, as you believe that 3 years is a suitable frequency for checking the accessibility of PIVs, and the submission of 3 yearly reports to the HSE provides a suitable opportunity for a progress report to be made, you believe that the inquiry should recommend that the HSE mandate each gas transporter to carry out a 3 yearly PIV accessibility inspection programme and progress on that inspection programme, and progress on that inspection programme should be reported upon in the 3 yearly report.
Yes.
So that's your clear recommendation. And just to clarify, you mean that PIV accessibility is something that should be included in the gas transporter safety case and then in the 3 yearly updates to the HSE?
Yes, it could be very easily a short section in the report. It focuses the mind
Yes.
of the management on
Yes.
progress.
Now, in terms of timescale, you say that reporting on this every 3 years is about right in your judgment.
Yes.
Can you just explain why you say that?
3 years, you can argue a fair bit can happen in 3 years, but you've got a 3-year reporting process already there. So in that sense, bolting the reporting process onto the safety case report. The PIVs can be lost because of resurfacing work, other utilities doing work and reinstating their trenches, and
Yes.
in the reinstatement doing away with the valve box. They can be lost because of landscaping work done by building owners. And if you're going to check on the accessibility of pipeline PIVs, as I say, if you've got a record of the PIV in the first place, then it's actually a very short duration job to actually check its accessibility.
Yes, because as you explained earlier, you don't actually have to activate the valve. In fact, you wouldn't recommend it.
I don't recommend that, that's right.
You literally just have to check that the chamber is there and that it's clear. Is
Yes.
that correct?
Yes.
So you don't think this is particularly onerous in terms of what it's imposing?
It's something that could be given to an individual with a van and a small set of small tools and a list and plans, and he would literally go from site to site to site. It's not a high-skilled job, and you can do far more sites
Yes.
than involved with the high-rise building surveys.
Yes. Now, Cadent has suggested that the draft building safety bill that we know has been presented to Parliament at the moment would give an opportunity to make a different identifiable party, i.e. the role of accountable person, responsible for ensuring that the PIVs are not covered up. Now, do you accept that that would be an appropriate way of addressing the problem of lost PIVs?
It would be an action that would assist in some circumstances.
Yes.
I would not expect the accountable person to have any involvement where the pipeline isolation valve is actually located in the public highway.
Yes. Because they would have no jurisdiction to be able to do anything about that.
That's correct.
Yeah.
I would not expect that person or organisation to proactively look after the pipeline isolation valve box. It's not something they're involved with. They have plenty of other things to be getting on with. They're not gas specialists and so not necessarily know the importance of them. And the responsibility for those valves rests with the gas transporter.
Yes.
So I would argue that it's part and parcel of the need for a proper dialogue and a proper relationship between the gas transporter and the responsible person for the building, stroke accountable person.
Yes. So is it fair to say that you think there might be a role for the accountable person in terms of them being the nominated point of contact for the gas transporter and assisting with challenges over accessing the building?
Yes, definitely.
But you still are of the view that the ultimate responsibility for checking the PIVs and making sure they're accessible should remain with the gas transporter?
Yes.
Is that correct?
Yes.
And this problem of lost PIVs, does that only apply to the high-risk buildings that might be covered by the draft building safety bill?
No, it's all commercial buildings and, if you like, blocks of flats where there's more than two consumers.
Yes.
So all the low rise and medium rise, as well as the high rise. If this building's got a pipeline gas supply and a pipeline isolation valve, that would come into it as well.
Does it not apply to ordinary domestic premises?
They don't have a pipeline isolation valve.
They don't have one at all?
They don't have it at all.
Do you think it would be sensible for the accountable person and possibly also the responsible person under the RRO, the 2005 Regulatory Reform Fire Safety Order, do you think it would be sensible for them not to have a duty not to cover up PIVs in any event and separate from your recommendation?
One can argue that if you could have, but I would ask the question: is it enforceable? I've got my doubts.
Right. Yes. The third recommendation that you make is about the standard for excess flow valves and thermal cut-off devices. We talked earlier about excess flow valves and thermal cut-off devices. And those are devices that can be fitted to pipelines that will cut off the gas supply if an open end starts discharging gas. Is that correct?
That's correct.
And this follows your observation that the flats continued to burn until isolation because of some open ends at the meters. Is that correct?
Yes.
Now, is it right that there's no requirement to specify these excess flow valves or thermal cut-off devices at the moment?
No, that's specified, or at least within IGEM G5, but the actual specification to which those fittings comply are actually German specifications. One could argue that we ought to have a British standard or a gas industry standard for those fittings.
Yes, and we can see that recommendation if we go to your first report, RHX 6012, at page 221. Yes, this is where you're dealing with that standard. Yes. And if we just read 476 and 477, you say currently there's no British or industry or gas industry standard for excess flow valves and thermal cut-off devices. You say there's German standards for both fittings and there's an American standard for excess flow valves. And you believe that the inquiry should recommend the gas industry, associated manufacturers and British Standards Institution produce a standard suitable for use in the United Kingdom. Is that correct?
That's right.
Yes, thank you. And then finally, the fire resistance of domestic meter installation components. That's your final recommendation. And we can see that below on that same page. And this follows from when we were looking at that photograph before of the resistance of each of the components of the meters. What you say is that there's no mention of fire resistance of other components making up a meter installation, i.e. pliable, go over the page.
Pliable connectors.
Yes. i.e. pliable connectors and the regulators. And you think there's a disconnect with the fire resistance requirements in Appendix A of Approved Document B because other parts of the meter are required to have fire resistance requirements of 30 minutes. Is that correct?
That's right. That's correct.
And having identified that gap, it's your evidence that the inquiry should recommend the gas industry and associated manufacturers ensure that the standards for the components of the domestic meter installation, other than the meter itself, address fire resistance. Is that correct? Yes. Now, it's been pointed out that there is a British standard for gas pipework for buildings up to 5 bar called BSEN 1775-2007. If we can just go to that, it's at BSI 401774. There we have it, gas pipework, gas supply, gas pipework for buildings, functional recommendations. And if we look at page 10, paragraph 3.2.1, it defines pipework as the assembly of pipes and fittings, and it includes regulators within that definition. We can see that at the top of the page. And then on page 16, at paragraph 4.4, it says, protection in case of fire, that the designer shall consider the possibility of an outbreak of fire within a building containing installation pipework that may cause damage to the fabric of the building and consequently or separately to the installation pipework. And then it says the design objectives shall be to minimise the likelihood of an explosion or serious aggravation of fire. And beneath that, we see a number of ways in which that objective can be met. And the third one talks about the use of materials, components and joints that withstand high temperatures. Now, it's not suggested that this goes as far as the recommendation you've made, which is to have a specific standard for regulators and other meter components. It doesn't set out any specific fire resistance requirements. But in addition to your recommendation, do you consider that there's an opportunity to cross-reference to this British standard or perhaps even to develop this standard further?
Well, this standard is currently being looked at by the French because it's an EN standard, but they're looking at it from the perspective of hydrogen. It's a functional standard. Some will argue, I believe, that having an automatic means of isolation at the meter, i.e. a thermal cut-off device, actually meets that requirement of this particular clause. So that's can be thrown into the mix if you're going down this route of looking at BSEN 1774. I certainly am of the view that it's having a regulator that can melt in a fire, as we saw at Grenfell, given that the components on either side have got some fire resistance. It's a weak point in the system.
Yes, thank you.
And the concern is that, yes, they're made of aluminium alloy. They're also used across Europe, I believe, in the same material. And so you'll have manufacturers who may not be willing to make them as fire resistant. So, it's an argument that's been put to me.
Right.
Nevertheless, I think it is something that needs to be tackled, possibly by, well, I say in the first instance by saying that the regulator should be fire resistant. The recommendation, I've used the word, it should be addressed.
Yes.
And so a viable alternative such as an automatic means of isolation could be argued as meeting that objective.
Yes, thank you.
But
yes, thank you. So those are all the recommendations you proposed. Final question for me. It's also been proposed that high-risk buildings with multiple occupation should have a record of engineering information relating to the gas services stored in a predetermined location known to or made known to maintenance engineering and construction contractors, so that they are fully informed about the gas services in that building. You haven't made a recommendation like this, but is that something that you would support and you would think that was a good idea?
yes, it will be covered in the edition 3 of G5.
Right, thank you. Mr. Chairman, I've come to the end of my pre-prepared questions. Sorry, I've finished slightly later than I meant to, but it's been good to get that topic dealt with.
Right. Well, thank you very much. Ms Hancox, at that point, as you probably know, we have to have a short break so that Council can check nothing's been left out, and also so that others who are not here but are taking a keen interest in our proceedings can make suggestions for any further questions that perhaps we ought to put to you. So we'll break now for 10 minutes and come back at 25 to 5 and see if there are then any more questions for you.
Yes,
all right?
certainly.
Thank you very much.
Yep.
Right. Well, we'll break 25 to 5, please.
Thank you.
Thank you. Yes, would you ask Mr. Hancox to come back in, please? Right, Mr. Hancox, let's see if there are more questions for you. Yes, Mr. Grange.
Just one question, Mr. Chairman. We've heard in your evidence that, in your opinion, there was in 2016 and 2017 a gas industry-wide knowledge gap about the importance of fire prevention and mitigation measures. Do you have any recommendations for the chairman as to how this might be addressed or improved within the gas industry?
I believe that will be addressed by the work that's being done by the construction industry council, I think it's called, which is looking at the competence not just of building engineers, fire risk assessors, etc. There's a lot of work going on with that. There will be a gas cohort in that, and I'm aware of what's going on there. So I think that is being covered by the effectively through the building safety regulator stuff. But yes, we address in the update of G5 certain fire safety stuff like fire stopping and references to or the difference between reaction to fire tests and fire resistance tests.
Yes.
Which Barbara Lane gave your presentation to the inquiry about. And that will be being picked up there.
Yes. So I think from what you've said, you're satisfied that the gas industry is already responding to this recognition that there was a gap in its knowledge.
Yes.
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 Thank you.
It's going to take time to fill that gap, but we've identified it and work is going on.
Yes, thank you. Yes. Thank you, Mr. Chairman. Those are the end of the questions. I'd just like to thank Mr. Hancox for all the considerable help and assistance he's provided to the inquiry. We really, really appreciate it. Thank you.
Well, it's right that I should add the thanks of all three of us on the panel to what Ms. Grange has said. We can see how much time and effort has gone into helping us and producing detailed reports, more than one. Speaking for myself, they've been very illuminating and interesting. Good. And we really are very grateful for all the help you've given us, and for the time you've offered us to come and give your evidence today. So, thank you very much indeed.
Thank you. Thank you.
Now you're free to go.
Yeah. Right.
Good. Thank you very much.
Thank you.
Right, Miss Grange. Well, that must be it for today.
It's it, and it concludes the gas evidence. And I think you have evidence on lifts, I believe, tomorrow.
We have other witnesses to come tomorrow to deal with other subjects.
Yes, you do.
All right. Well, thank you very much. Well, we break there for the day, and we shall resume at 10 o'clock tomorrow morning with another witness. Good. Thank you. 10 o'clock tomorrow.
Thanks.